Colleagues, welcome to the second session of today. According to the program, we're going to be witnessing a historic occasion where the Minister of Telecommunications of the Republic of South Africa will be signing an agreement with the Corporation for National, with the Donor Foundation, with respect to the use of the digital object architecture and the setting up of the MPA. Without a waste of time, because of, I think there are other activities which we need to fit in today. I'm going to be asking Dr. Ken to come forward and to discuss with us how to build the foundation for innovation and to provide an overview of the digital object architecture. Dr. Ken is one of the people who has been associated with the internet right from its beginning. He's worked in aspects of the internet which did not deal with the transportation, but which dealt with how the information is going to be handled. I think in his brief overview, he's going to be discussing then the emergence of the digital object architecture, its potential usage, and why all of us actually should be interested in this phase, is this next phase of the internet. Dr. Kerr, please.
So I got to navigate two different laptops up here, but I think we can do that. So, first of all, Dr. Sternbucke, thank you very much. I'd like to specifically say I'm happy to be here. I'd like to thank the government of South Africa, Dr. Quille in particular, for their wonderful welcome and stay in this country this past week, and I look forward to many productive interactions with them in the future. I was asked to talk about innovation in the context of the digital object architecture, but this is kind of a difficult thing to do. So what I'd like to do is first point out a few things about innovation just to kind of set the stage. And then I'll get into more details about what the architecture is and why it's important and why we should all take advantage of it. I actually put together a set of slides, but I think I'm not going to go through the slides. I'll make the whole slide deck available to the folks to share with you so you can go through some of the kind of detailed, and we don't really have enough time to do that. But to first order, I want to talk a little bit briefly about innovation, then get into the internet and how its objectives were met, how it's evolved over time, talk about how the issue of managing information fits into that context, and then close by talking a little bit about how we guide infrastructure evolution in the future, because this is not the end of the road by any means. It's a very early part of the long-term journey for society around the world. So immediate contributions to any society really depend upon having robust capabilities within the country, or at least accessible to the country, for development. I'm thinking of contributions from industry, from academia, and certainly from government, because in many places without a government awareness of what's going on, to say the least, major changes in society that will be beneficial really are hard to make happen. But probably more important than anything else is the empowerment of young people who can dream large dreams and have access to enough resource to try and explore their ideas, because that's where the future is really going to come from. And a big part of that innovation is really intrinsic to the individual. So you can teach about infrastructure, you can teach about applications, and many people do learn about that. But what does it really take to be innovative? I happen to be a golfer, not such a good one anymore, but I used to play varsity golf in high school and college. And learning golf is really a prerequisite to being able to play the sport. but it doesn't guarantee that you'll become a world-class golfer by any means, even if you know all the rules and are taught exactly what to do. That part really is intrinsic to the individual. So similarly, innovation in the IT world and communications requires the knowledge to be able to play in this arena, but it also requires some basic intrinsic capabilities to imagine a future, to understand how to take those ideas and turn them into reality. You know, infrastructure development, which is something that I've focused on a lot, is a very subtractive kind of process. If you're a painter, you keep adding brush strokes to a canvas to produce a result. But when you're a sculptor, you kind of take things away. And an infrastructure is really at its most powerful when it doesn't have a lot of extraneous material in there. It provides the minimal set of capabilities that different parties can build upon. If a new capability is widely needed, well, maybe you add that to the infrastructure. But in general, you've got to learn how to make infrastructure simple and basic, or it won't be adopted widely. Now, I believe the internet was such an innovation when it was first introduced some 40-plus years ago. But more important than the original ideas, which interestingly enough have pretty much stood the test of time, because they were so simple and essential, is how people have developed this over time and enabled it to evolve. To put this into perspective, during the period of the internet, this 40-odd year period, the telecommunications speeds have gone up by a factor of about 1 million. The computational speeds have gone up also by a factor of about 1 million. And the amount of memory that you can buy for the same price has gone up by about a factor of 1 million. Assuming the internet doesn't go away anytime soon, a decade from now, it'll be a factor of 1 billion. And there really is nothing in the history of technological evolution that leads itself to conclude that a technology should last over that wide a range of capability increase. So why was that? I mean, why has the internet been able to last that long? Well, first of all, it's because it was independent of the underlying technology. I mean, there are many people who mistakenly think that the internet is the same as the components that make it up. I mean, the internet consists of networks and computers and users and cell phones and applications of all kinds, but what the internet was about, the protocols, made those all interconnectable. It made it possible for the information to flow to the right places. In the internet environment also, it was defined as an open architecture. That is, nobody was all of the interfaces were kind of transparent and visible. You knew what the protocols and the interconnections were to plug things together. So it really was kind of plug and play. But even more important than the technology were the social systems, the social networks that were developed that have been really critical in evolving both the technology and the applications, but also for enabling people to engage with this important development. And I could name a number of the early ones. I mean, we were involved. You surely would know about the IETF, which we helped to create and then administer for almost 2 decades. You probably know about the IAB, both in its earlier form of the Internet Activities Board and its later form, the Internet Architecture Board. I actually signed the papers to incorporate the Internet Society. I actually did some of the ICANN functions before we were even thinking about ICANN. And of course, ICANN is now a central player in this also worldwide. There was something called the ICCB that most of you probably don't know about in the early days. And in recent years, things like the IGF have played an important social role in this process. So why did the internet flourish? Well, we have the social mechanisms to allow it to grow and evolve. But an important need of people over the years has been the need of institutions as well as people to access information, to interact with each other, and to share information very broadly and efficiently. Well, I became concerned about our lack of a good architecture for managing information in the mid-1980s, and I set out to develop such an architectural approach along with my colleague Vint Cerf, who was employee number 2 in our firm. I was number 1. And we developed an approach based on mobile programs. Oh, great, thank you. Based on mobile programs in the internet. Well, this was a time when viruses were first being introduced, and many folks were concerned about accepting mobile programs onto their systems, especially if they were written by others. And many folks were also asking us, well, how would the average citizen learn how to program these mobile programs? Well, to make progress, we decided not to fight that battle back then. I think its time will come again in the future. But we decided to progress without the mobile programming aspect. And so the result was the digital object architecture that I'm briefly going to describe. This has actually been evolving steadily over the past 15 or 20 years. We've had productive discussions with a variety of individuals and their organizations as to how this particular architecture can address some of the important concerns that they have that are currently not being addressed by existing capabilities. And I look forward to continuing those discussions. I think you would be amazed at how widespread the set of possibilities are if you have the right architectural basis for thinking about information. So I'm going to just take a few minutes to kind of philosophize about that. The digital object architecture is about managing information. And this architecture has much in common with the internet architecture itself. In fact, I consider it to be a logical follow-on or extension of the internet. It is not only compatible with the internet technology, but in fact, it makes use of so many aspects of it that it becomes almost seamlessly integrated with it after a while. I've encouraged people to think of this as a positive addition to the internet because it's going to enable things to get done that don't have an easy way to deal with them today. Now, we could take any one case and we could argue, can you do that today? Can you not do that today? What are the problems and the like? But there are many issues that we do know that we have, and I guess I would start with the issue of persistence. There are many reasons why one may want information to be around for a very long time. So what is persistence? Persistence of the identifier, to me, means you can resolve it to find out what the identifier is supposed to tell you about the object. Another one is persistence of the information itself. And that's an interesting question because even if you could identify the information uniquely, and even if you could access the set of bits, you may not be able to manifest the information that's there in a form that you can understand it. Well, what does it take to do that? Today, well, maybe you need to, if it's a proprietary data format, maybe you need to have the program that knows how to interpret it. Well, but that program may need an environment in which to operate. The very first spreadsheet program, I think, was one called VisiCalc. And if you got a VisiCalc spreadsheet sent to you as an attachment by email today, you would have a very difficult time figuring out how to figure out what that spreadsheet was. Because even if you could find a version of the VisiCalc program, I believe it ran on DOS 1.0, which was one of the earliest Microsoft platforms, and you'd have to find an environment that would run that environment and so forth. So it becomes very, very difficult. And I think one of the challenging research issues is not so much how to continue to understand proprietary formats or even open formats for which you need kind of templates to interpret them to be maintained over time, but how you can take the information itself and express it in a way that it can be recreated for the programs of the future to have to deal with. Another important issue is interoperability of different systems. Now, this is something that we solved with the internet in terms of connectivity. So you could move bits from one place to another without having to worry about what network the final system was on, how do you get there, what protocols to use in the middle. We really had a pretty unique and common way of doing that. But in the world of information, it's very easy to fall into the same trap that we did early on when we thought maybe there'd be one network for the world and everybody would connect to that. But the reality is it's literally one network in the sense of being provided by one organization with one administration. It's not clear who that could ever be and satisfy every country in the world. So the internet today, you can think of as being like a network. I think of it as the protocols and procedures for stitching all these pieces together. But we will have interoperability issues of a very different nature in the information world. The web today has been a major contributor to people's ability to access information today. But what happens if we have 2 or 3 or 4 different kinds of information systems, even in the near term? Somebody comes up with a really interesting different way to represent. How do you make those work together? There is this interest in the so-called Internet of Things. Well, the very first networks were networks of things. Computers were things, so we're just back in the same situation again, except these things now are, instead of million-dollar computers, they're devices of all kinds, and who knows what they will be in the future. But rather than thinking of these devices as like a temperature sensor where you go to read a temperature at the moment, you can think of this sensor as producing a whole raft of information, a lot of information over a period of time, maybe even storing it right at the sensor, and therefore the sensor becomes an information system in its own right. And so you very quickly will be in a world where you have all these different information systems, potentially all different, that need to interface with each other. So that's another challenge that I think we need to deal with. I might point out that the internet protocols were really ad hoc for the first 10 or 15 years, and it was only when they became more in widespread use that the need for actually formalizing the standardization and evolution of them became necessary. I think the same is going to be true for the digital object architecture. There are protocols, they are in widespread use, but there were conscious decisions made not to formally standardize them, but I think we're going to need to be doing that in the very near term. So what is this architecture all about? It's all about how do you think about information? And most people haven't really had to focus on that before. When the web came around, organizations had to, for the first time, think about what information could they put on their website because the public could access it. Before that, it was mainly advertisements that they might put in newspapers or signs that they might put on the exterior of their building. But they had to come to grips with what could be made public and what not. Governments have the same thing, although in their case there are actually occasionally laws that dictate what has to be private and what has to be public. But if we're in a world of digital objects, in principle, we could have such a large number of them over time that it's hard to even articulate how big that number could be. So how are we going to deal with the question of which of our digital objects should be public and which of our digital objects need to remain private? Well, you probably will, the old adage, information wants to be free, except if it's your bank records, except if it's your health records, except if it's, private corporate information, except if it's sensitive government information, except if it's X and Y and Z and so forth. So it's going to be a challenge to understand that, and you're not going to want to do it after the fact. You're going to want to categorize this when it's created to know maybe you can decide nothing can be public or maybe everything can, but probably those are not the right answers either. So from an infrastructural point of view, we're going to have these digital objects. What's a digital object? It's a set of sequence of bits that's got a unique persistent identifier. Now, if you just have a set of bits with no identifier, you have no way of grabbing it. That's why we call these identifiers handles. It's a way of, grabbing hold of that information, so to speak. But, just like on a regular computer, if you're typing on a keyboard, it doesn't automatically become a file. You've got to actually put it in the file system, give it a name so you can eventually access it and retrieve it. And the same thing with digital objects, except they can be now anywhere on the globe, not just in your own system. So the the components of this architecture are, starting with the digital objects, which is kind of the lingua franca of, like packets were to the network environment early on, IP addresses were to, the ability to route them uniquely. Well, digital objects are the lingua franca of the digital object architecture, and each one has a unique persistent identifier. I'll get into the question of how this uniqueness is carried out in a minute, but let me just say that repositories are the architectural thing that allows you to store these objects. Because if you've got an identifier for a digital object, one of the things you might want to do is access that digital object, or tell somebody else about it so they can access it. And a repository, in the parlance of this architecture, is not the storage medium itself. It's not the disk drives or the cloud services or the RAID arrays. It is literally the interface to a management program that knows how to get the information from the identifier. So all the accesses are by identifiers, which mean any two repositories then can interface with each other because they're dealing with each other by identifiers. And the identifiers can be not only for the object that you want, but also for the action to be taken on the object that you want, which might be embedded in the repository software. It might be something that you then want to access, download, and possibly use or vet before using. In this architecture, the assumption we make is that virtually every entity has an identifier. So every individual would have an identifier that would resolve to information about the individual that they wanted you to know about, like their public key, maybe their contact information for that day, if they cared to make it available. The repositories could interface with each other, but these repositories basically need to know what's inside of them, because the party that owns it may want to know that. Likewise, if you don't remember the identifiers, if there are really a lot of them, then the architecture introduces the notion of a registry, which you can then search to find identifiers. So the reason that that's interesting is, unlike the web where you're searching publicly available stuff, this can be used to actually search through private materials, because you have the choice with security as to who to make that information available to. So every one of these components has reference implementations. We built most of them. I think others have built some. They're all available open source on the internet, so you're free to use them. But they were intended as a kind of a template for what to do, so people would understand that this isn't just a paper written here in the hope that somebody would figure out how to make this work. Well, it turns out that if registries contain metadata about the objects so you can find them, then the registries need repositories to store those metadata records as digital objects. Likewise, as I said, the repositories need registries so you know what's in that. So we put the two of them together, and there is now a system on the net which we call Cordra. And Cordra is essentially an amalgamation of a registry and a repository. So instead of downloading one repository and one registry, each of which contains the other, you can now download one thing that has both of them, and you can use it whichever way you want. In my view, the opportunities to make use of this architectural capability are virtually unlimited. If one had asked me back in the early 1970s, what could you do with the internet, I would have said, almost everything I can imagine, and that's going to be a tiny subset of everything the rest of the world imagines. And as we've now seen, the way the internet has grown, it's very different in terms of application than it was back in the early days. Architecturally, it's very much the same. So how do we respond to the challenge of evolving this architecture and managing its evolution? Because most of the people that care the most about this are in the business of dealing with information. It may be the people who curate information that's large data sets of research data, oceanographic data, medical data. There's the big data challenges and initiatives, and maybe just the libraries or the publishers, the people who make movies. But rest assured that what we now think of as kind of an information structure is going to evolve in the future. I mean, the book of the future is probably going to be a package for lots of different things. You go to see a movie, it's not just that you watch the moving pictures, there's a soundtrack behind it. So you may find music that's keyed specifically to the action on the screen. Likewise, you can imagine reading a book that has music packaged in with it to go with the text that you're reading, or it may have, well, certainly photos are common in books today, but you might have spreadsheets that are actuated by it. These data structures are going to evolve. And even the things that you download from the internet could look very different in the future, especially as bandwidth goes up. So example I like to give is you might download a map. And well, we have maps today in cars and on our cell phones. But as you're going through that map, you might want to say, well, what's that building on the right? And when was it built? And you'd like to do it sort of immediately. So along with the map, you can imagine they might have a knowledge attachment that might be hundreds or thousands or even millions of times larger than the map itself. Well, maybe the map has to come quickly, but these attachments can come in more slowly, and how you process it and send these through the net and how you manage it will be a function of what the data structure is. Today, the networking world doesn't know much about new data structures when they show up because they're all prepackaged ahead of time. But if you had a dynamic environment to deal with something that was brand new, it'd be nice to be able to find out about it in the time it takes to process it and send it on in some appropriate way. So let me put some numbers on the table. I said we might have a very large number of digital objects, but you know, if every laptop and every smartphone and every computer for that matter had a repository in it, we could easily have one per person. That would be probably 10 billion in the not too distant future. That's assuming every little baby and every elderly person had one, but let's just make that assumption. And I can easily imagine 10 to the 40th repositories. That's a very large number. So if somebody gave you an identifier and said, you know, take a look at this, which of those 10 to the 40th repositories do you ask? It's only going to be in one or a small set. The answer is you don't know. You're not going to build that into the identifier. The identifier could even be a cryptographic string. It could be, you know, a semantic string, but it's not going to tell you which of these trillions or trillions of repositories to try out. So people then suggested, well, you know, we need the equivalent of a card catalog that'll help us sort that out. We call these identifiers handles. That's just our term for it. People call them other things. Publishers call them DOIs. The Europeans are calling them PIDs. There are a variety of names, and everybody is free to brand their own, so they can call their the important thing is that they resolve, that you don't have to have 100 different resolution systems to figure out what the identifier really means in practice. But those identifiers can be managed by a much smaller group of organizations. But let's say there are 1 million organizations. Right now there are probably more than 10,000 that are contracted to do that or have downloaded software and are just running their own. So which of these tens of thousands or maybe million, a much smaller number than the repositories, do you ask? And the answer is you still don't know, and you don't want to try all of them. So what we ended up doing was coming up with a structure for an identifier that essentially assigns a unique number to an organization so they can create identifiers. They could number their objects 1, 2, 3, 4, 5, and if every organization in the world did that, you know, that's not sufficient. But if you prepend this unique number to their I have a slide that I can show you what that looks like in practice. But if you give one of these, we call them a prefix, to an organization and say, put that in front of every identifier that you create, and we keep a record of these prefix records, then you can take an identifier, you can say to this global registry, who has the prefix? And if there are only 1 million, that's a fairly small set of records to keep. You then know which resolution provider to go to ask for the handle record, and that will tell you in turn which of the 10 to the 40th repositories might have that record. It might tell you some other things too, like how you authenticate this information, what the terms and conditions are for use of it. You can't tell that on today's internet. You can learn about public keys in case you need to invoke PKI, which is an integrated part of the security here. So the global registry is really the only linchpin in this whole system. And the question was raised with us probably 8 years ago by a number of different parties. They said, well, what happens if CNRI stops providing this function for whatever reason? We go bankrupt, we lose interest, whatever. And I said, well, what would you do if ICANN went out of business? You're using the internet. ICANN is doing an important function. And he said, well, we're sure that that would all get worked out. The carriers would pick it up, governments would pick it up. It's too important. Well, okay. Then give this enough time. If there's enough uptake, then nobody's going to want this to fail either. But the feeling was maybe we should have distributed administration of this. There's one piece of the global root which just says what numbers are being handed out to people to create their own identifiers. So about 6 years ago, we made it possible for multiple parties to administer the global root. Very interesting, but we also made it possible for them to share with security that information with everybody else who was administering the global root. And about 3 years ago, we created a foundation in Geneva after lots of discussions about what would be an appropriate place to coordinate this. Because there were questions raised about, okay, suppose you have 10 administrators around the globe. Who gets to decide who can be the 11th? And oh, by the way, if they're sharing this information, how do you do it securely? So certain records are going to need to be signed, keys need to be kept, and so forth. How does that all work? So I have some slides on that. I'm going to see if I can just show you how we work that one out. Okay. So I gotta get used to this particular. That do it? That do it? Okay. How do I get this to keep going? No, go back. Go to this one. Well, let's see. Yeah, that's the one I want. How do I play that all out? Okay, I get it. Okay, so here is what the architecture looks like in broad brush. You got a client in the upper corner. Now this one I know how to work. If I can get it. Except I can't see my pointer. Okay, anyway, upper left-hand corner is the client, repositories, the identifier resolution process, and then resource discovery at the bottom. Those are the registries. Now what I want to do is go all the way to the end here. You can look at, this will give you a feeling. The handle system is actually conceptually really easy, but when you break it out, it's like the internet. It's conceptually really easy, except when you look at the details, there's a lot of detail in there. Conceptually, this is really easy, but there's been years of evolution of this technology to actually get to the records. The systems that are run can be whatever the individual party chooses, and the metadata slide is all about assertions, but this is where I wanted to get to. Oops. Oh, shoot. Hang on. Now what? Let's try that. Okay, so you got right to the end. Okay, good. So, you can see on this slide that we ran the original global handle registry. It's shown as a GHR on the slide in the U.S. since the mid to early Actually, it started out about 1993, but it wasn't widely used until maybe the mid to late 90s. Until recently, we had the sole role in giving out prefixes, but we decided to split it up and spread the administration. So the current GHR is backwards compatible with all the legacy handles, but we now have these multiple administrators. So the foundation was organized in January of 2014 in Geneva. There are 9 members currently on the board of directors, but it can grow to as many as 25. Of those 9 members, I'm one of them. I chair the board, but there's one other member from the United States who was responsible for opening up the internet internationally in the early days when he was at the National Science Foundation. There are 4 members from Europe. One is from Russia, one is from China, and one is from Africa. The gentleman from Africa is from Mali. He was the president of the PrepCom for the very first WSIS in 2003, Adama Samaseku. This foundation really provides the overall administration of the Global Handle Registry. It will support the relevant standards that are tightly tied to the operation of the digital object architecture. It will get involved in outreach activities. The executive director will meet with different parties, give talks, help them plan pilot projects, and if we can raise funds from the appropriate parties, we actually play a role in actually running the pilot projects or participating in it. At the moment, we have 5 organizations that are administrators. They've actually signed these MPA agreements. My organization is one of them because we were the only one initially, and we have most of the agreements in place today. But there's one group in Europe that is involved with the large research data sets. It's run out of the University of Göttingen. It involves the Max Planck Society. It involves DataSite, a big supercomputer center in Finland, and others. There's a coalition in China consisting of a research part of the government, a technology firm in the private sector, and an investment firm that will invest in startups. They've been doing some interesting things in managing the food process, whether it's getting beef to market and wanting to know the history of the particular piece of beef that you just bought. Who are the parents? Where were they raised? What were they fed? Where was it slaughtered? What issues occurred with them? Maybe even something about their parents. Infant formula was another one. There was a lot of counterfeiting going on, and so they found a way to use this architecture to deal with counterfeiting of infant formula. So the International DOI Foundation, which was one of the first to make use of these identifiers for managing publications, recently became an MPA. Their motivation actually started in the mid to late 1990s when they became concerned about publishing journals in digital form in the internet and wanting to not have to go back and change all the citable references at the back every time a publication moved from place to place to place. And so they found that this was a very good solution. And in fact, most of the major scientific, technical, and maybe medical journals use this as the method of identifying their publications publicly. And the other one was it was actually a commission in Saudi Arabia dealing with their industry, academia, and others. And I think they want to play a larger role in the Middle East as well, so we'll have to see how that goes. We're talking about several others, but we've had serious discussions here in here in South Africa for the last year, I would say, and they've made enormous progress. I was very surprised at how in-depth their analysis of this was, how broadly they're thinking about it, and so the anticipation is that we will sign this agreement after the session with South Africa. So I think we will have 12 MPAs altogether by the end of 2018, which is enough to support the foundation because it gets its support from the MPAs directly, but it's only for the narrower purpose of managing the oversight of the registry and keeping the standards process going. Administratively, it looks like this, if you can see it. There is this foundation, which is a nonprofit organization. It's got international credentials from the federal government, and it's being watched over 10-year periods by the canton. It basically does the credentialing, as I said, signs the credentials, and handles the overall administration, including all the keying materials. And every MPA operates independent of every other MPA, and stringent conditions are in place to make sure that no one organization can affect the operation of the other organizations relative to their customers. So I think that's an interesting development, and it's one that is being looked at very carefully, and so far it's worked pretty well, and it's going on 3 years old. So I think I want to conclude my remarks there. I did want to point out that this, even though the folks who have been most interested in this have been in the traditional content-related industries, we're finding there's interest in the networking world as well, because they need to know in more detail about what it is they're communicating. Users need to know more about what to do with the information that's received. And if the original model that I had been easy to implement some 25 or 30 years ago, we would have had programs explaining to the protocols what their needs were. The protocols taking the steps to make sure that that's the way they provided information. It would be packaged at the source that way. But that was not really an achievable thing all the way back, because we're dealing with existing operating systems, existing applications, and the like. But I think we are moving in that direction, and the use of a digital object architecture can help in letting both programs and operating systems and like learn what they're dealing with in the future. So I expect that with this coalition that is being put together here in South Africa, becoming one of the administrators, that it will be an active participant with others in evolving the DOA and its application, not only in Africa, but also around the world. So once again, I'd like to say thank you to Dr. Quille and all the people that have made our stay here so enjoyable and informative, and we look forward to lots of further interactions with you in the future. So thank you very much.